Okay, so hey everybody, this is Mr. Bells again. This is for Geo B. This is section 1-4 out of your textbook, and here's some information for you guys. So again, Geo B 1-4, Geo A 1-4, and today is all about perimeter, and area. So these are two concepts that you guys should be pretty familiar with. So the first thing, if we're going to talk about perimeter and area, we want to know perimeter and area of what? So let's take a shape right here. So this is a shape that's connected by 1, 2, 3, 4, 5 different segments. And there's a whole bunch of names that go with these things. But the general thing, whether it's a three-sided or whether it's four-sided or five-sided, all of these things that are connections of segments that don't dent in here or do dent in, whichever they are, they're called polygons. They just don't cross over each other. So polygons. This one happens to be what's called a pentagon, triangle, and a quadrilateral. And you'll see if you have your textbook open, this is on page 30 in your textbook. These are the different names for them. And when we go above 12, we don't really have a special name for an 11, but when we go above 12, we just consider that an n-gon, whether it's 20 or 30 or 40 or 50 or whatever it is. And the more your number of sides get closer and closer to infinity, the closer that thing looks to become a circle. Okay, so polygons. So what we have in this thing, we have this point right here. This is called a vertex of a polygon. And let's say this was A, B, B is a vertex, also C, D, and E. So there are two different ways to be able to measure things. One, we could measure how far it is from A to B, and then add from B to C, and then add from C to D, and then add from D to E, and then add from E to A. And that distance all the way around is called its perimeter. So how far it is all the way around a shape. And then if we wanted to say, like, we wanted to fill this whole area up inside, all of that space inside that polygon is called its area. So perimeter goes around it, and it's measured in straight line distances. Good deal. Area measures it by shape. So like I could take a whole bunch of circles and put them in here, but if I put a whole bunch of circles in here, there's these gaps in the middle, and these gaps just don't like, see this little gap in here, we can't put all the same size circles in there. So we measure areas in terms of squares. Okay, how many squares fit inside this thing? So if I take this along there, I got so many of these squares that will fill up this space. And that's why perimeter might be measured in inches, but area is measured in square inches. But that doesn't mean that I'm squaring the number. That simply means that that's the shape of the unit. So 15 square inches, like that, really means 15 1-inch by 1-inch squares would fit inside that. Okay, so we need some formulas right here. So here are some of your basic formulas, perimeter and area formulas. So for a triangle, perimeter is length A plus length B plus length C. That's all the way around. Area formula is 1/2 B times H. So B stands for the base, and a height is anything that's perpendicular to a base that goes through the opposite vertices. So you can see that this is the opposite vertice from this base, opposite up here, and the height is the distance straight down so that it's perpendicular to it. A square perimeter is 4 S's because it's a square, they're all the same side, so 1, 2, 3, 4 of those S's. Area is side squared, so if this was 3 by 3, let me give you a little picture of that right here. So let's go a 3 by 3 square, so 3, so there's 1, 2, 3 lengths there, and 3, 1, 2, 3 lengths there, you can see obviously that a 3 by 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9 total squares. Okay. Now if they were inches, that would be 9 square inches. If they were centimeters, it'd be 9 square centimeters. But I want to make sure we understand this. This doesn't mean there's an 81 in here in any way, shape, or form. It means that there is 9 of these little squares that happen to be 1 centimeter by 1 centimeter in length. Okay? So let's say that we had this. Let's say that we had a point at 4, 6, another point at 7, 8, and another point at, let's go, -3, comma, -8. Well, if I was to plot these points on my coordinate axis, 4, 6, and I'm just going to do a quick little sketch of this. 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's my 4, 6, 7, 8. 5, 6, 7, and 8. That's up there. And -3, -8. 1, 2, 3. -3, -8. That's way down there. I'd have this triangle on there. It looks like this. Well, if I do my distance formula right, I know that I could add this length, and this length, and this length, and I could get a perimeter. And I just need to use my distance formula for that. Okay, if I wanted to find my area, I'd probably want to find out this length right in here, but that, for these numbers, it's going to be a little bit tougher. The ones and examples in the book are going to be a little bit easier. Okay, but perimeter. So here we go. I'm going to try and do this really quick. In fact, pause the video, see if you can come up with the perimeter to the best of your ability. Let's say rounding in the 10th spot. So pause it right now, see if you can come up with the perimeter, and then you can turn it back on and see if it worked out for you. Okay. So, did you pause it? Okay, I'm going to go ahead and do this here now. So here's A, here's B, here's C. The first thing, I'm just going to put them on here. 4, 6, 4, 6 is this one. So that's A, 7, 8, that's B, and C is way down here. So I'm going to find the distance between A and B. Now when I'm done, it should be pretty small, right? I should not have a very big number. If I get a number bigger than 8 right now, I'll be like, oh, sketchy, that's not right. So here we go. Find the distance between 4 and 7, that's 3. 3 squared is 9. Find the distance between 6 and 8. 6 and 8 is 2. 2 squared is 4. So 9 plus 4 is 13. So I got the square root of 13, which is approximately 3 point something. Let's pull out the calculator here. So 13 raised to the 0.5. Remember, raising to the 0.5, same thing as square rooting. So I'm going to do 3.6, and I'm going to say I can round it enough to that. That one's good. Okay, so that's 3.6. That's where my distance is. Now I'm going to do this one. I'm going to do A to C. That's this point to this point. So how far is it from 4 to -3? That should be 7. 7 squared is 49. How far is it from 6 to -8? 6 to -8 is 14. 14 squared, maybe I'll pull my calculator out here again. 14 squared is 196. So I need the square root of 49 and 196. Remember, keep your negatives straight, right? So 6 to -8. 6 to 0 is 6. 0 to -8 is 8. So 6 and 8 is 14. You can also think of subtracting the two numbers. 6 minus -8 becomes 6 plus 8. 6 plus 8 is 14. So let's do 196 plus 49, enter, raised to the 0.5 power, and I get 15.65. So now I've got another one that's 15.65. I'm going to kind of hold off on those hundredths right now, and then let's do the last one from B to C. Now visually, this is the longest one, right? So here we go. So one more time. A to B was 3.6. A to C was 15.65. Now I need B to C. Okay, so here we go, B to C. So 7 to -3 is 10. 10 squared is 100. 8 to negative 8 is 16. 16 squared, I think it's 256. Magic calculator does say 256. So plus 256. And again, the more you know some of these numbers in your head, the better off you are. So I need the square root of 356. So 356 raised to the 0.5 power, and I get 18.87 if I round it off. 18.87. So I need to add this number, and this number, and that will get me the perimeter of that triangle. And I believe that you guys can do that stuff. Okay. Area formulas again. Let's say that I had this right here, this rectangle, and this was 4, and this was 7, and I wanted to know perimeter. Perimeter. Perimeter would be 4 plus 7 plus 4 plus 7. All those sides added up, and I get 14 and 8. Perimeter is 22. Let's put centimeters in here so I have some units. So 22 centimeters. And if I wanted to know the area, that's obviously or at least my picture is trying to show it's a rectangle. Let me put in some right angles in here so you know that, and some congruency marks so you know that. Notice I did 1 and 1 for congruency marks. Those two are equal. And I did 2 and 2 to show that those two are equal, but a 1 doesn't equal a 2, so that those are two different sides. So area, according to that thing, is length times width, so 4 times 7, so the area is 28 centimeters squared, or like I like to write a lot of times, 28 square centimeters, so that you know you're talking about 28 of those little 1 centimeter by 1 centimeter squares that would fill the sucker up. One more quick little visual on that. If I did 4 and I did 7 on 1, 2, 3, 4, 5, 6, 7. If you count up all those squares, guess what you get? You get 28 of them. So what does some of these problems look like in here? So if you take a look at your textbook, it will say something like this. Find the area of the polygon with the given vertices. And it gives you a 3, 1, a 3, negative 2, and a negative 2, negative 2. Well, obviously, 3 points, 1, 2, 3, that's probably going to be a triangle. So let me go ahead and plot those things and see if you can find a base and find a height for that triangle. And again, they should be pretty easy on here to be able to determine where they are. And again, examples that go through here. Remember, just because I did something in a video doesn't mean you can't look at some of the stuff. So this is finding the area in the coordinate plane. It gives you an example. It's going to take you step by step, show you how to use things like the ruler postulate to be able to find a distance. Like this one, I'm just going to kind of do that, ignore that for a second. So if I'm trying to find the area of this thing, well, I know my base could be this one right here, right? Well, my height would be this length right here. And I don't need to use the distance formula for a vertical line. I can just count boxes, right? So the height is 1, 2, 3, 4, 5, 6 boxes up. And the base is 1, 2, 3, 4, 5, 6, 7, 8 boxes over. So 1/2 6 times 8. Half of 6 is 3. 3 times 8 is 24. So 24 units squared, or 24 square units. So this is kind of what I'm going to get from here. You can go through and try some of the other problems. I think you're going to be okay with it. So one more time. Perimeter and area, Geo A, section 1-4. The problems or the area formulas that I showed you in the textbook work out for you. A couple of keywords that I didn't put on it, but you should probably know. So this, and this, these are all considered convex polygons. Concave polygons are ones that dent in, or basically that means this. If I was to take any 2 points on any polygon and I connect those 2 points, all the points should lie in the interior of the polygon in order for it to be convex. Notice here, if I connected these 2 points, none of those points lie on the interior of the polygon, so that's why it's considered concave. Concave also kind of think of it as means it's dented in. Good deal. I hope this helped. You guys take care again, and we'll see you back here soon.